In this screencast, we're going to discuss how to implement caching using aspect-oriented programming, specifically with PostSharp. Typically, in most applications, caching is somewhat of an afterthought. It's something that we go back and add once we have an application either in testing or in production environment, when we notice that we have slow performance on some of the methods that we execute. And typically the ones that we try and target for caching are the slow running methods. So this could be things like complex database queries or long running web services. Now, sticking to our banking example that we used in the first screencast, the only data that we really retrieve is bank accounts. So we'll try and cache those. And as you can see, we already sort of have a standard way of caching it without using aspect-oriented programming, where we build the key, which is comprised of the class name, the method name, and then the parameter and the parameter value that's passed in. We check to see if the item exists in the cache. If it doesn't, we go ahead and call the repository, our data layer, to retrieve the account, and then we add it to the cache with the appropriate key and return the account. So it's a pretty standard caching pattern. Let's take a look at the repository. And typically there are two schools of thought on how to implement caching. Some people argue that the proper place would be in the data layer. So they would say to wrap this whole statement in a caching statement and return the cached value from here. I'm sort of the school of thought that the appropriate place would be in a business layer. In case we need to do any sort of business logic manipulation on the data after we've retrieved it, we can cache the manipulations that we've done as well. So that's why I have it in the business layer as opposed to the repository layer. Now let's take a look at what the cache does. This is a pretty crude implementation of a cache. Now you could certainly use, and I would recommend to use, something like the Microsoft caching application block or a distributed cache such as the Velocity Project or Memcached. But as we can see, all the basic functionality that you would expect to see in a caching system is present. We have a method for getting an item from the cache. We have one for removing an item from the cache, and one for adding an item to the cache. And we have an override of that as well, which enables us to put a timeout value for how long the item would persist in the cache. In our case, it doesn't do anything, but in a real implementation that would. And then we have this method. This is called generate key, and what this enables us to do is build a unique cache key based off of the parameters that are unique to a method. Now this is important for the reason that when we have a method that accepts variable parameters, we wouldn't want it to have the same cache key. Let's say, for instance, we were trying to cache the method getAccount. We wouldn't want the key for getAccount of ID 1 to be the same as the key for getAccount of ID 2. So this takes the parameters that are unique to this method and builds a key that include the type of the parameter as well as the value of the parameter itself, and then it returns the key. And let's think about how we can start ripping some of this out, because while this is the only implementation that we have in our business layer that is cacheable, there might be some other ones added later. So let's go ahead and create an aspect for it. So we'll go over to our aspects folder and we'll add a new class, and we'll call it cache attribute. We need to make it public, serializable, and once again we'll have it extend the on method boundary aspect. So let's go ahead and add our onEntry override. We're doing this because we want to catch the actual target method before it's executed, because we're going to do our check to see if the item exists in the cache there. So we'll say onEntry. Now the first thing that we're going to want to do is go ahead and build the cache key. So we'll say string key equals, we'll start off by saying args.method.name, and we'll append cache.generate key, and we'll pass in the arguments that are passed in as part of the target method. Now we'll go ahead and try and retrieve the object from the cache, so we'll keep it as a base object class because it could be anything. So we'll say object value equals cache dot get, pass in the key, and then we just follow our simple caching pattern. So we'll say if value equals null, we'll set the args dot method execution tag, which we can use later in other overrides of the aspect, equal to the key. And what we're doing is we're storing the key someplace in the aspect so that we don't have to compute it at a later time, which we'll see in a little bit. If it's not null, in other words, if we were able to retrieve something successfully from the cache, we'll say args.return value equals value. So we're setting the return value for the method equal to the object that we pulled from cache, and we'll say args.flowBehavior equals flowBehavior.return. So it's pretty simple. Once again, we're just building the cache key. We're trying to retrieve the object from the cache using the key that we just built. Were we able to successfully pull something from the cache? If not, we're just setting the method execution tag to the key so we can use it later here in a bit. And if we were able to pull something from the cache, we want to go ahead and set the method return value equal to the value that we were able to pull from the cache, and then tell the method to just return. So that we're almost done, but the thing that we need to do now is override the onSuccess method. So this happens when the target method successfully executes. So the first thing we're going to do is we're going to create our cache key again. So we'll say string key equals args.methodExecutionTag.toString. And all this is doing is getting the value that we set up here on the onEntry. And then we simply say cache.add key args.returnValue. And it's important to note that the onSuccess will only execute when the target method successfully returns. In other words, if we intercept it and pass a return value from the aspect, this onSuccess method will never fire. So let's go back to the banking service, and we're going to remove a lot of this code. And we'll just apply our attribute. And it's that simple. Let's go ahead and set a breakpoint here, and we'll set one here, and we'll see what happens. So let's go back to the core of the application, the program, which starts us all off, and we'll remove some of these lines, and what we're going to do is just duplicate this line, so that way we're calling bankingservice.getAccount for the same parameter twice. Now, one last thing we need to do before we run this is we need to go back to the cache, and we need to create an override for the generateKey method. So we'll say public static string generateKey, and the argument type will just be arguments, and we'll just say arguments for the parameter name. And all we need to do is call the other instance of generateKey, passing in arguments.toArray. This arguments parameter not only houses the individual arguments that are passed into the target method, but also includes some contextual information about them as well. We just need to return this here. Okay, let's go ahead and run the application. Okay, and you'll notice the first thing that happened was we hit the onEntry method. As expected, this executed before the target method, which was getAccount. So let's step through the execution and see what happens. Now we're going to check to see if we're able to pull the value from the cache. Should be null, which it is. We set the method execution tag equal to the cache key. And then you'll notice we're back to our banking service. We're getting ready to execute the account repository method. So we notice it returns there, And the next thing that happens is that it hits the onSuccess method. So we successfully pulled the key from the method execution tag, and now we're adding the item to the cache. So now this is the second call that we've made to the method of getAccount for account ID of 1. So we should build the same key this time, which we did, and we're going to check to see if the object exists in the cache, which it should. We set the return value equal to the object that we pulled from cache, and we tell the banking service.getAccount method to go ahead and return, which it did. And that's pretty much it. We can see with just a few lines we made caching much easier in our application. All we have to do is add this caching attribute to any method that we wish to cache, and it would be done. And that does it for part 1 of implementing caching using PostSharp. In this screencast we've covered how to intercept the method boundaries to get information pertaining to the target method, build the cache key, and store the return value from the target method into the cache. In the next screencast we're going to cover more advanced topics such as compile time validation to ensure that the method that the cache attribute is applied to makes sense to use for caching. So stay tuned.